Good afternoon. Welcome to my laboratory. I just wanted to check and see if I could get a decent voltage reading on this system. Now, of course, the plasma is highly electrically conductive, so whenever the plasma is actually going on, the power supply is seeing pretty much a dead short, and so the voltage output will drop. And I wanted to find out just how much the voltage output will drop. The power supply, of course, is this zero voltage switching Royer type oscillator using two IRF P260 MOSFETs in there, and I'm powering that with bench power supply down there. The top number there, 11.9, is the voltage, and the bottom number, 000, is the amperage it's putting out, and then that's the other side we're not using over there. That's powering the oscillator, and the oscillator is powering the flyback transformer, which is there in oil. The oscillator drives that 10-turn center tapped primary, and then we're using the flyback's high voltage secondary coming out that red wire, positive, and the ground return is the white wire. So I've disconnected the red wire from the apparatus and just have it hooked up to the voltmeter, and I've got the voltmeter in its highest range, which is 15,000 volts. Let's just see what happens. There's a lot of glare from the overhead light, and it's hard to see the thing without shadowing it. But let's check it out. Okay, so we're plugged into the 1500 volt range, 15 kilovolt range, and now I'm going to go ahead and turn the flyback on, or rather the driver on. Oh, the ceiling fan is really distracting. Let me turn off the ceiling fan. Wind that down. Okay, so here we go. Driver coming on now. Boom. Okay, so that's at 11.9 volts and just over half an amp input with no load except for the meter, and we're seeing we're in the 15 range, so we're seeing right at 9 kilovolts right now, 9,000 volts. So let me turn up the meter, or turn up the power supply until we hit the top of the range at 15 kV right there. So at 19.4 volts and about 9/10 of an amp input to the board, the flyback is putting out 15 kV unloaded. And you may recall that I'll go up to 24 volts, 26 volts sometimes with the input to this. Okay, but that's with the system unloaded. What's going to happen when we hook it up to the plasma, and the plasma is essentially a short circuit? So stay tuned for that while I change the hookup around. Okay, welcome back. Now I've got the system hooked up as before. The chamber is actually pumping down right now. It might already be pretty low. And I've still plugged into the 15 kilovolt range of the meter. So I'm going to, let's see where we're at right there. We're on the 0. So I'm going to turn the driver on now. Point. And we have plasma. It's not completely pumped down yet, but there's certainly a good plasma glow going in there. and we're at 11.9 volts, and we're 3.06 amps, which is normal. But the voltmeter needle just barely came off the bottom peg. So let's change ranges. So I'm going to turn the driver off, and then we'll take this out of the 15 kV hole and we'll plug it into the 1500 volt hole, 1.5 kV, and turn the driver on. Nice plasma, and we're pumping down, so the plasma is getting better. So now let's see what the meter reads. Now we're in the 1500 volt range, so the 15 is there. So we have 300, we have about 450 volts showing on the meter here. Full scale would be 1500 volts, 1200, 900, 600, 300. So 450, just under 450 volts on this meter. Okay, so I think this shows that the plasma is highly electrically conductive, and that it essentially shorts out the power supply. At this 11.9 volts input to the driver unloaded, we were seeing, I think it was 9 kilovolts before, right? So let me go ahead and turn up the voltage here until we get 24 volts. Which is the highest that I've been running this guy at. So 24.3 volts, a little 5.35 amps input. The buku glow in the chamber. These white spots are glare from the overhead lighting. And the voltmeter reads about 500 volts. And before, remember, this 24 volts was giving, we didn't even get that high. The 19 volts was giving us 15 kV output. Okay. Thank you for watching.